better place. We are smart at what we do to make our world a better place. By the help of God, to make our world a better place. By the help of God, to make our world a better place. Smart do.
Okay. Greeting to you all. We are running about the action of metals with oxygen. But I want us first of all to look at how do metals burn in air. I want us to deal with a few metals so that we can tell how they do it. We talked of burning in air, or burning is called combustion. So how do the metals burn in air? And what factors should I consider when I'm thinking of how a metal burns in air? So, for us to know this, let's do some simple experiment. Take a small piece of sodium metal, a very small piece, holding it with the tongs, and then heat it on a Bunsen burner frame. Make your observations and your conclusions. Repeat the experiment using calcium, then magnesium ribbon, a piece of iron, and finally a piece of copper. I've talked of 5 metals. And then, just like in sodium, make your observations, and then let's draw our conclusion. I want now to mention about the observation we should expect. When a small piece of sodium is heated strongly on a Bunsen burner frame, it sparks and burns with a yellow flame. When the experiment is repeated using calcium, you heat calcium, you hold the calcium piece using a pair of tongs, and you heat it strongly on a Bunsen burner frame. The calcium burns with a yellow flame. When the experiment is repeated using magnesium ribbon, the ribbon burns with a brilliant white flame. Don't leave either of those words. A brilliant white flame. When the experiment is still repeated using iron, a piece of iron, no apparent burning is seen, but the iron grows red, grows red, and finally when it cools, it will turn to brown. Copper, on the other hand, when the experiment is repeated using copper, the copper does not burn, but it turns black. That means there must be a chemical reaction that has occurred, because copper is brown, then when you heat it strongly, it turns black. That means there is a chemical reaction, but it does not burn. We don't see it burning. Now, let's turn to each at a time. When sodium is heated and it burns with a yellow flame, the sodium reacts with oxygen from air to form sodium oxide. Sodium plus oxygen. This oxygen is from air. You form sodium oxide. You are not supposed to use symbols at Form 1, therefore I have to write the name sodium oxide. Calcium burns with a yellow flame, an orange flame. Calcium plus oxygen from air, you end up forming calcium oxide. On the other hand, magnesium plus oxygen from air, you end up forming magnesium oxide. Then copper or iron. Let's first of all talk of iron. Iron plus oxygen from air you end up forming iron oxide. Then copper plus oxygen from air, you end up forming copper oxide. This copper oxide is the substance that we have said it turns black. Copper oxide is black. That is why, while copper is brown, then when you heat it in air, it will turn black because you have formed copper oxide. Now, I want us to realize one thing, that the reaction of the metals with oxygen from air also depends on the reactivity of the metal. Sodium is very reactive, therefore it is burning. Calcium is relatively less reactive, but it is still burning. But when you come to copper, copper does not burn. In fact, no apparent reaction is seen. But we still form the black substance copper oxide. To conclude, I want to tell you this, that the reaction of the metals when heated in air depends on their reactivity. And as we go to nanometals, we will still see the same trend.